Hello everyone. In this video, I am going to talk about section 4.5, moment of a force about a specified axis. In the past, we learned about moment using the scalar method. Magnitude of the moment will be force multiplied by the distance, where this distance right here is defined as the perpendicular or shortest distance from the point to the force of line of action of the force. And that point we define as the rotation point. So this concept can be extended to find the moment of a force about an axis. In this figure above, moment about the y-axis would be my equals fz times dx, where dx equals r cosine theta. Now, looking at the force here, it probably will be complicated to resolve our forces into the x component, y component, and the z component, same as the dx, right? So calculation is not always simple and straightforward. And this is why we are going to introduce the vector analysis, which makes the calculation a little easier. Vector analysis here, our goal is to find the moment of f, which is the tendency to rotate a body about the a-axis. First, we're going to compute the moment of f about any arbitrary point O that lies on the a-axis using the cross product. So moment equals r cross f. The next thing is that we're going to find the moment along the a-axis using the dot product, u8 dot m0. So these, we put it together, we can also call it a triple scalar product. ma equals u8 dot parentheses x cross f. Okay, we're going to put this in the 3 by 3 matrix. Over here, the UA represents the unit vector along the a-axis. R is the position vector from any point on that a-axis to any point A on the line of action of that force. And F is the force vector. Let's take a look at an example together. We have a force shown in the figure. We're looking for the magnitude of the moment of the force about the x-axis. So using what we defined here, triple scalar product, we have mz equals u dot, and then with the parentheses r cross f. So u axis, we know that it's going to be along the x-axis. That's why the u axis is going to be I, just one I, right? And then the ROA, we look at it a lot in the past few videos, looking at your O as your 0, 0, 0, and we're looking for the coordinate of A, and we will have the ending point minus the starting point, which is the coordinate of A minus the coordinate of U, which gives us the ROA. That goes to your second row. And then lastly, we have F over here. Three angles are given, 45 degrees, 60 degree, and 120 degree. We can use the three cosine 120, cosine 60, and cosine 45 to find the ijk component of the F. Putting this in the triple scalar product form and to get the actual value of the moment, the result come out to be 17.4 Newton meter counterclockwise. Okay, counterclockwise means that we get a positive value and it's counterclockwise. Next example here, similarly, very similar, we have the force 30 Newton at this angle, alpha, beta, gamma are all given. And then it's rotating about the axis AA. And the moment of F about, we're looking for the moment of F about axis AA. And since it's rotating about axis AA, we know that the UA is going to be J, because that AA is parallel, look, parallel to the y-axis. AA axis and the y-axis, they are referring to the same thing. So that's why UA is J. And then OA, again, we're looking at the O, and we're looking at the A, right? So ending point minus the starting point. Now be careful over here. This A right here does not have any value on the J component. No J, because it has 0 on the, there's no coordinate on the y-axis, the y value is going to be 0. And then your x, so your 0, if your 0 is down here at the O, x will be this much. Okay, let me try it again. My bad. X value, let me use green. X value will be this much, which is 100 millimeter. But however, look, X is positive going this way. And A relative to the O, point A is negative 100 because it's going toward a negative direction of X. That's why you have negative 0.1 on the I. Okay, and then the K component, the Z component will be 100 plus 50 going positive. Okay, now the force F will have cosine 60, and cosine 45 to find the components of the F. Putting in this triple product form, we can get the value of M. So this is all I want to show you for section 4.5. Thank you for watching. Hope you understand how to find the moment of a force about a specified axis. Have a good one. See you in the next video.